Dear students, welcome to our class on wind profiles on bare ground. Wind profiles on bare ground. The climate near the ground, when bare ground is there, when crop is there, are the fundamental things that micrometeorologists shall understand and apply to solve the problems of the farmers. Now, see, here the first diagram is on laminar motion of air. Laminar motion of air, this is the first one. The second one is the turbulent motion of the air, and the third one is the typical wind velocity profile or bare ground. Now, see, in earlier classes I have discussed at length with you on what is laminar motion of air. In the laminar motion of the air, over the bare ground, okay, wind velocity gradient appears in between moving plate and the bare ground. This is the bare ground, this is the moving plate. The wind velocity gradient appears as the wind force is going on slowly increasing, not decreasing, okay, from the ground. Now, in the turbulent motion of the air, what happens is same bare ground, same moving plate. However, the laminar layer, when it expands, wind speed increases. As the wind speed increases or force increases, so turbulent layer is formed. Eddies are formed. In the typical wind profile, velocity profile, what happens? This is the bare ground, like here. There is no moving plate here. Typical, what is here? Here the extra thing is uniform airstream. Where the uniform airstream is there, first is the laminar layer, then is the turbulent layer, laminar layer, turbulent layer. Above this there is a uniform airstream. Now, so let us conclude it one 4 or 5 important points. What are how the wind profiles over a bare ground exist. This is there in your syllabus, PG and Ph.D. That's why I'm just going to the basics of micrometeorology here. Because of frictional drag exerted by the ground, because of this question will come 100%, please understand. Because of the frictional drag exerted by the bare ground on the wind, the wind speed increases with increasing distance from the ground. It is assumed to be 0 at the surface. Usually at the bare ground, the wind speed is assumed to be 0. Consider the motion of the air sandwiched between a moving plate and bare ground. The air next to the plate is dragged along by frictional forces of the ground are dragged. Now, if the flow is laminar, in this case, if the flow is laminar, the sandwich layer will have number of thin slices of moving with different velocities. Thin slices of air moving with the different velocities. Here is less, here is more. Now, if the velocity of the plate is increased, moving plate is increased, then what will happen? Turbulence is generated. This is turbulence is generated. That's what. Now, usually the thickness of the laminar boundary layer is of the order of, usually it will be millimeters, maximum centimeters, not beyond that. Okay. Now, to calculate the flux densities, it can be assumed that the density of the air is constant and that mean velocity is 0. Mean vertical velocity is 0. From there on we can calculate it. At this crossing, this is very important question. Most important, in no book you will get this one. At this crossing from one layer of the atmosphere to another, take with them the average properties of that layer. At this crossing from one layer to other layer, they carry with them the average properties of the layer from which they are going. So this is what I would like to discuss with you. Once again, I would like to impress upon you that this is a typical wind velocity profile over the bare ground, laminar, and this is turbulent. Thank you very much.